So more examples on basis. If V1, V2, V3 is a basis for vector space V, then show that U1, U2, U3, where U1 is V1, U2 is V1 plus V2, and U3 is V1 plus V2 plus V3, is also basis for the same vector space V. So this is V1, V2, V3 is a basis for vector space V, and therefore dimension of V is 3. And this set contains U1, U2, U3 contains 3 vectors from the vector space V. And so in order to show this set is basis, we have to show just only one condition out of the two conditions, that is either show this set is linearly independent and or the show this set spans this vector space V. So we will show this vector, this set is linearly independent. So let K1, K2, K3 be scalar such that K1 U1 plus K2 U2 plus K3 U3 is equal to 0. We have to show this U1, U2, U3, this set is linearly independent in order to show the set is basis. So let K1, K2, K3 be scalar such that K1 U1 plus K2 U2 plus K3 U3 is equal to 0. And then substitute U1, U2, U3 as V1, V1 plus V2, and U3 as V1 plus V2 plus V3. And then collect the coefficient of V1, V2, and V3. And this set V1, V2, V3, this set is a basis, means this set is a linearly independent. And therefore, this linear combination of V1, V2, V3 is equal to 0 implies the coefficient of V1, V2, and V3, that is these scalars, K1 plus K2 plus K3 is equal to 0. This K1 plus K2 plus K3 is equal to 0, and K3 is equal to 0, because V1, V2, V3, these vectors are linearly independent, because these V1, V2, V3 is a basis for vector space. We means this set V1, V2, V3 is a linearly independent, and therefore the linear combination of V1, V2, V3 is equal to 0 implies all these scalars are equal to 0 by definition of linearly independent vectors or set. The coefficients all are equal to 0. So we have 0, and therefore solving this, we have K3 is equal to 0. Substitute in the above equation, we have K2 is equal to 0, and substitute both the values in above equation, we have K1 is equal to 0. So we have K1 is 0, K2 is 0, K3 is 0, and therefore the set U1, U2, U3 is linearly independent, and therefore as the dimension of vector space V is 3, and this set U1, U2, U3 contains 3 vectors and is linearly independent, and therefore S is a basis for V. So write this sentence after this, that S is linearly independent, then write dimension of V is 3. The set S is set of vectors in V contains 3 vectors from V, and the set S is linearly independent, so S is a basis for vector space V. Determine the dimension and basis for solution space of the system. So this is the system. We are given 2 equations and there are 4 unknowns. Now we have to solve this system, and we have to find first solution space or solution set of this system. So in order to solve any system, we apply the Gauss elimination method. So form the augmented matrix as the matrix of coefficient and matrix of constant matrix, its combination 1, minus 4, 3, minus 1, 0. And then the second row is 2, minus 1, 5, minus 3, 0. So we have to reduce this matrix to echelon form. So this element is 1. Now we have to reduce this 2 to 0. So the application is transformation is R2 minus 2 R1. So we have first row as it is, second row this is, okay. So minus 2 minus 4 become plus 8 minus 1 7 in this way. Minus 6 plus 5 is minus 1, and minus plus 2 and minus 3 become minus 1, 0 as it is. And then we have to reduce this 7 to 1. So 1 by 7 R2, we have this, and this is an echelon form. So rewrite the equation. So the first equation is x1 minus 4x2 plus 3x3 minus x4 is equal to 0. And the second equation is x2 minus 1 by 7 x3 minus 1 by 7 x4 is equal to 0. And so after rewriting, what is your observation? There are 2 equations and 4 unknowns. What are that unknowns? x1, x2, x3, x4. And these are the 2 equations. So assign 4 minus 2 is equal to 2 unknowns. The difference between the 4 unknowns and 2 equation is 2. So assign 2 unknowns. So we assign x3 as t and x4 as s. Or we can assign x3 as 7t as a 7t and x4 as 7s in order to avoid this fractional. Or we assign x3 as t and x4 as s, where t and s are any real number. So either use the notation T, S, R, M, L. Okay. So in order to assign the uh, uh, unknowns. So we have x2 from equation number 2. X2 is minus plus 1 by 7 x3 plus 1 by 7 x4. So substitute x3 as t, x4 as s. We have this. And then from equation number 1, x1 is shift this all this quantity to RHS, and then substitute x2, x3, x4, and we have the value of x1 as minus 17 by 70 plus 11 by 7s. Okay, and therefore the solution set or is called solution space. So what is the solution set? Right in curly bracket, right? This curly bracket, that in round bracket now. Write the value of x1 as minus 17 by 70 plus 11 by 7s, comma, one. Write the value of x2. X2 is this 1 by 70 plus 1 by 7s, comma, the value of x3 is t, value of x4 is s. Such that write this line. Then t and s are belongs to are real number. T and s are any real number. So this is the solution set or solution space of this system, given system. This is the solution space or solution set of the given system. Now take this t as common and s as common. So when we have the t in a round bracket, the 4 tuple minus 17 by 7, then 1 by 7 coefficient of t. Coefficient of t is 1, and in the last component the coefficient of t is 0. So write 0 plus yes. The coefficient of 11 s is 11 by 7. Here 1 by 7. In the third component, z component, there is no s, means its coefficient is 0, and in last 1. So such that t and s belongs to, and therefore the basis for solution space. So this space spanned by these two vectors, and therefore the basis for solution space or solution set is this contains, right in curly bracket, these two vectors minus 7, 11 by 7 plus 1 1 comma 1 by 7 1 0 comma 11 by 7 1 by 7 0 1. And so there are two vectors in the basis of solution space of the given system, and therefore dimension of the solution space is 2, because this set contains, the basis contains two elements. Okay, so the basis, the dimension of any vector space is equal to, is what? Is the number of vectors in its basis. So there are two vectors in the basis, and therefore dimension of solution space of the given system is 2. Okay, so this is the problem. We are also solve such a type of problems in the next topic. So that is the find the basis and dimension of solution space of the system. So we will see more problems in the next topic of such a type, that is find the basis and dimension of solution space. So this is solution space, and this is the basis and the dimension of solution space. So this is solution space. So we have first solution space, then its dimension, basis, and then its dimension. So next example is s is equal to x, y, z, such that 2x minus y plus z is equal to 0. Then find the dimension of s. So s is actually the set on which this is the condition, is subset of R3. So we consider this equation 2x minus y plus z is equal to 0. So there is only one equation and there are two unknowns. So we assign two unknown. So we assign y is equal to t and z is equal to s, or similar to this. Like this, there are two equations and 4 unknowns, so we assign 2 unknowns. Like that, this is a single equation and there are 3 unknowns, so assign 2 unknowns. See, one equation and 3 unknowns. So difference is 3 minus 1 is equal to 2. So we assign 2 unknowns. Suppose y is t and z is s, and therefore from this equation x is what? X is plus t minus s divided by 2, and so this is the value of x. Substitute y as t and z as s. So we have x as t minus s by 2, or 1/2 t minus s. Okay. So, or we write 1/2 t minus 1/2 s, 1/2 t minus 1/2 s, and therefore s is equal to, so write x as t minus s by 2, comma y is t, z is s, such that t and s belongs to R. So similar to like this, we have the solution space, solution set, and then take t and s as common. So we have t in bracket 1/2, 1 and 0, and then take s as common plus s minus 1/2, then 0 and 1. such that T and S belongs to R. And so basis for S, the basis for this set S is what? Is the two elements, right, in curly bracket, the in round bracket now, 1/2, 1 comma 1 comma 0, this vector and this vector. Okay, so these two forms the basis for the set S, because S is the linear combination of these two vectors. S is the linear combination of these two vectors, and so these two forms the basis for the set S, and therefore dimension of S is 2. Same type example, W is x, y, z belongs to R3 such that x is equal to y. So equation is x is equal to y, or x minus y is equal to 0, like this. We have x minus y is equal to 0. That is z variable is a free variable now. There is relation between x and y only. So if you assume x is t, then y is also t, and so z is s. So again we are given the one single equation, x minus y is equal to 0. What is the equation? X is equal to y means x minus y is equal to 0. So we have the single equation, like this single equation, and there are uh, three unknowns, x, y, and z. So assign two unknowns. Now the relation between x and y is only given, means z is the free variable. So if you assume x is t, then don't assume z as y as s, because x and y are related to each other. So if you assume x is t, then y is also t. Or if you assume y is t, then we have x is t, and z is free variable. So suppose z is s. So x minus y is equal to 0 is the given equation, and there is one equation and three unknowns. So we have to assign two unknowns. So we assign x and t, x and z. Okay, and then x, because x and y are related. So in this example we can assign x, y and z, or x and z, or y and z, or x and z. Okay, or y and z. Okay, so we assign any two, but in this example we have to assign x, out of x and y we have to assign one of them, and then z. Z is compulsory. In this example we can assign x and y also, and find the value of z in this fashion. Okay, because the x, y, z are related. So but here z is free variable, so we have to assign out of x and y one variable, and then z. Okay, and then we have w is equal to t, because x is t, y is t, and z is s. T and s belongs to R. Then take t and s common, so t in bracket 1 1 0 plus s 0 0 1 0 0 comma 1, round bracket complete, such that t and s belongs to R. Then basis for w is these two sets, these two vectors, 1 1 0 comma 0 0 1, this right in curly bracket. So this set is a basis for w. This set contains two vectors, two elements, and therefore dimension of w is 2. So these are some problems of the dimension and basis of solution space. Actually, the standard basis for Pn is again 1x x squared divided dash x raised to n from the standard basis for Pn. Pn, what is Pn? Is the vector space of all polynomials of degree less than or equal to n, less than or equal to n. So write this sentence correctly. So what is Pn? Pn is the vector space of all polynomials of degree less than or equal to n, and therefore dimension of Pn is n plus 1, because these are n plus 1 in number. This is 1, this is 2, this is 3, like that. This is n plus 1th number vector. So this set contains basis of the Pn contains n plus 1 vectors from Pn, and therefore dimension of Pn is n plus 1. 1x x square is the basis of P2, this P2. Okay, so dimension of P2 is 3, because there are three vectors in basis of P2. Similarly, 1x x square x cube is the basis of P3, and that's the dimension of P3 is 4. So these are some problems for homework exercise, so that these three vectors are linearly dependent. So we start with the sentence that let k1 k2 k3 be scalar such that k1 u1 plus k2 u2 plus k3 u3 is equal to 0 bar. That is 0 bar means 0 0 0 0 portable. And then apply the definition of scalar multiplication, vector addition, and comparing the LHS and RHS. We have the system and solve the system, and then find the value of k1 k2 k3 that are not all 0, and therefore these three vectors are linearly dependent. So similarly show that this polynomial P1, P2 and P3 form linearly dependent set in P2. So I can start with the sentence that K1, K2, K3 be scalar such that K1 P1 plus K2 P2 plus K3 P3 is equal to 0 bar. What is 0 bar? 0 plus 0x plus 0x square. And then substitute P1, P2, P3, collect the coefficient of constant coefficient, coefficient of x square in LHS and compare LHS and RHS. We have the system and solve the system. And then we observe that the values of K1, K2, K3 are not all 0. And therefore these three vectors P1, P2, P3 are linearly dependent. Determine whether these three vectors are form linearly dependent set in R3. That is why to determine whether U1, U2, E3 are linearly dependent or independent. So answers are given. Answer are given. Yes, 11. Answer 11 is S. That is these vectors are linearly dependent. Okay. Which of the following sets of vectors in R3? So R3 is a vector space, are linearly dependent or independent. Okay, so the question mark, that is where to determine whether these vectors are linearly dependent or independent. Okay, so there are two vectors from R3. So in order to determine these two vectors from R3 are linearly dependent or independent, we have to denote these vectors as V1 bar and this is V2 bar, and then start with the sentence that let K1 and K2 be two scalars such that K1 V1 plus K2 V2 is equal to 0, and then find the values of K1 K2. If all are equal to, both are equal to 0, then we say that the given two vectors are linearly independent, and one of them is not equal to 0, then we say that this set is linearly one of them both are 0, then we said the set, these two vectors are linearly independent. So answers are given. Here is the answer, not A. These are these two vectors are not linearly dependent. Okay, the question is linearly dependent. So these two are not linearly dependent. So these are two are not linearly dependent and linearly independent. Similarly, this is the example. So we have to solve this example by taking K1, K2, K3 as scalars, and similarly the next example. But in the answer of the D, we can directly give the answer of this D as these three vectors are linearly dependent, because if there is a 0 vector, then the vectors are linearly dependent, or that set is linearly dependent. If the set contains 0 vector from that vector space, then the vectors are linearly dependent. So these three vectors are linearly dependent because we have the scalars not all 0, such that their linear combination is 0. So like this 0 into this plus 5 into this plus 0 into this is equal to 0, 0, 0. That is, we have the coefficient of these three vectors are 0, then 5 and 0, then their linear combination is 0. That is K1, K2, K3 are not all 0, and therefore the set is linearly dependent. So obviously, very obviously, if the set contains 0 vector from that vector space, so what is 0 vector of R3? The 0, 0, 0, this 3 tuple 0, 0, 0 is the 0 vector of R3. If the set contains 0 vector, or then the set is linearly dependent, and therefore if the set contains 0 vector, then set is not basis of R3. Okay, because when the set becomes a basis of R3, if the set is linearly independent, but if the set contains 0 vector, then set is linearly dependent, and therefore the set is not basis of R3. So this set, that is the set of these three vectors, is not basis of R3, or these three vectors does not form the basis for R3. Similarly, this set is what? Is linearly dependent. Why this set is linearly dependent? No need to find the values of K1, K2, K3, K4, the values of K1, K2, K3, K4 in this example. But in the first three examples, we have to find the values of K1, K2, K3. But in the second, this D and E, we can write directly answer that this set again of these four vectors are linearly dependent, because we know the theorem that dimension of R3 is 3, and therefore any set contains more than 3 vectors from R3 is linearly dependent. So no need to find the values of K1, K2, K3, K4. So we can directly write that this set is linearly dependent. But we cannot write this set as linearly dependent or independent directly. This set contains two vectors. But we can say that this set contains these two vectors is not basis of R3, because the basis of R3 contains exactly three vectors. Okay, and which the set is linearly independent. But there are two vectors, so the set contains two vectors is not basis of R3. But we cannot say this set is linearly dependent or independent directly. But this set contains four vectors from R3, and we can say that these four vectors are linearly dependent, or the set contains these four vectors is linearly dependent, because dimension of R3 is 3, and so any set contains more than three vectors is linearly dependent. So write the answers. This problem is where to find the value of alpha, lambda, so that these u1, u2, u3 are linearly dependent. Already the answer of this problem is given in the previous lecture. So explain each of the following case. Is the set is not basis for the corresponding vector space. That is, this set u1, u2, u3 contains these three vectors 2, 1, 4, 3, 5, 2 is not basis for R2. Why is not basis for R2? Because dimension of R2 is 2, and therefore any basis for R2 contains exactly two vectors. That is, the set contains more than two vectors or less than two vectors is not basis of R2. So this set contains three vectors, and so the set contains u1, u2, u3 is not basis for R2. So this is the subset of R3 1, 1, 1 and 1, 1, 0. And again, this set contains two vectors, and R3 is what? Dimension of R3 is 3, and that is any basis of R3 contains exactly three vectors from R3. So this set contains two vectors u1, u2. So these two vectors, the set contains these two vectors is not basis of R3. So again, this is the next example. This set of u1, u2, u3 is not basis of R3, because there is a zero vector. One of them is zero vector. So 0, 0, 0. And if the set contains zero vector, then it is not a basis of R3, because the set is linearly dependent. The set u1, u2, u3 is linearly dependent, and therefore the set is not basis of R3. Again, P1 and P2 these two elements does not form the basis for P2, because again the dimension of P2 is 3, and so the set contains two vectors from P2 is not basis of P2, because any basis of P2 contains exactly three vectors. So this is again the set of ABC. This is the subset of M2 by 2R. All these A, B, C are the elements of M2 by 2R. M2 by 2R is the what? A, B, C, D, E. This is the 5 element from M2 by 2R. And so, but the dimension of M2 by 2R is 4. And so, no set less than 4 vectors or greater than 4 vectors from M2 by 2R is a basis of M2 by 2R. So, the set contains these 5 vectors is not basis of M2 by 2R. Similarly, these three vectors u1, u2, u3. So this is the basis of this is basis of, we have to check whether this is basis for R3. So we can check whether this set contains three vectors is linearly dependent or independent. But if you observe, if you multiply by -1/2 to this, -1/2 to this, then we have this. So this element is multiple of this, and so this set is not linearly independent, and therefore we say the set contains these three vectors is not basis of R3. So by observation we can give the answer of these problems. Or the last problem, we can also check whether this set u1, u2, u3 is linearly dependent or independent by taking scalars. Let k1, k2, k3 be scalars like that. K1 u1 plus k2 u2 plus k3 u3 is equal to 0 bar, and then find values of k1, k2, k3. We observe that all k1, k2, k3 are not equal to 0, and therefore this set is linearly dependent, and therefore this set is not a basis of R3. Okay. Determine which of the set is a basis for R2. So this set, we have to determine these two, give reason. So this set we have to solve this example. Let k1 and k2 be two scalars such that k1 v1 plus k2 v2 is equal to 0. That is determine whether this set containing these two elements is linearly dependent or independent. But we can say this set is not basis of R2 because this set contains zero vector, and therefore this set contains these two vectors from R2 is linearly dependent. uh, for this example, apply the procedure. So this set contains only one element from R2 is again not basis for R2 because dimension of R2 is 2, and so set contains only one element or three elements. This set E in E, if the set contains more than two elements or less than two elements from R2, then it is not basis. So this set contains this single element is not basis, or the set contains these three element is not basis. Okay, determine which of the set is basis of R3. So the first one contains three vectors. So we have to check whether these three vectors forms linearly dependent or independent. So we have to apply the procedure for these three examples. That is, we have to determine the values of K1, K2, K3. So suppose K1, K2, K3 are all equal to 0. Then we said the set is linearly independent, and then set becomes a basis for R3. Okay, so in order to first three examples, we have to solve the example. But the fourth number example, we can give the direct answer that this is not basis of R3 because this set contains four vectors from R3, and dimension of R3 is 3. So any set contains more than three vectors or less than three vector is not basis of R3. So similarly, this set contains two vectors, so it is not basis. In order to solve this last example, we have to take the K1, K2, K3 scalars and where to find the values of k1, k2, k3. That is, we have to determine whether this set contains these three vectors is linearly dependent or independent. Okay, so apply the procedure. Again, we have to show this set is basis for m2 by 2r. That is, we have to show the set contains this four vector is the basis of r2 m2 by 2r. Means this, we have to show this set is a linearly independent. Okay, so like k1, k2, k3, k4 be scalars like that. K1 into this plus k2 into this plus k3 into this plus k4 into this is equal to 0 bar. That is the matrix of order 2 by 2, zero matrix of order 2 by 2, that is 0, 0, 0, 0. Then find the values of k1, k2, k3, k4, and if all are equal to, we have that the values of k1, k2, k3, k4 are equal to 0, and therefore the set is linearly independent. And then we write the sentence that m2 by 2 dimension of m2 by 2 r is 4, and this set contains four vectors, and this set contains four vectors, and this set is linearly independent, and therefore by using the theorem, this set is the basis of m2 by 2 r. So these are the answers of these problems. So these are also by introspection we have to determine these sets are not basis. So this is not basis of for R2, R4, R3 because this contains four vectors. Again, this is not basis because this contains two vectors and dimension of P2 is 3. So this is not basis of for R2 because this set contains three vectors from R2 and dimension of R2 is 2. So the set contains three vectors more than two vectors, and therefore it is not basis. Again, this is the set contains two vectors from m2 by 2r, and this m22 is the vector space, its dimension is 4, and so the set contains two vectors is not basis for this. And in order to solve this example, we have to find the values of k1, k2, k3, or if we multiply by 2 to this vector 1, 2, 3, then we have this vector 2, 4, 6. That is, this is scalar multiple of this vector, and therefore this set is linearly dependent because one of the vector is a linear combination of the remaining two vector, and therefore we can write this vector as 2 into this plus 0 into this. That is, this vector is a linear combination of remaining two, and therefore we say this set is linearly dependent because we know the theorem that the set is linearly dependent if and only one of the vector in that set is linear combination of the rest of the vector series. So which of the following set is basis of R3? So we have to determine these sets are basis or not basis. So we apply, we first determine the sets are linearly dependent or independent by procedure. So again, here is also the, we have to determine the values of k1, k2, k3. That is, we have to determine the values. These sets are linearly dependent or independent. We cannot not directly write the answer. So that this is the basis for m2 by 2r or m22. M22 means what? M2 by 2r. The vector space of all 2 by 2 matrices. So this is about the topic linearly dependent, independent, and basis. As far as the exam concerned, this topic is very important, that linearly dependent, independent, and basis for a vector space. So we have all the standard basis of R3, R2, R4, M2 by 2R, P2, P3, Pn. So learn. So we can write first the standard basis of all vector spaces and then their dimensions. So if the final exam is MCQ type, then then this topic is very important. That is, what is the dimension of R3, what is the dimension of R2, what is the dimension of M2 by 2R, what is the standard basis for M2 by 2R. These are the MCQ questions. So whether this set is linearly dependent or independent in R3. So this set is linearly dependent because this set contains more than 3 vectors. Dimension of R3 is 3. So such a type of questions are MCQ type questions are on this topic. So as far as the exam concerned, this topic is very important. Linearly dependent, independent sets or vectors and basis for a vector space. So we will see the next topic, coordinate and coordinate vectors, in the next lecture.